The next episodes of Thriving Construction come straight from Future Build. Huge thanks to Eco Cocoon. The space was great for chats, acoustics, and even better well-being.
So quite often when people hear geothermal, they think Iceland, they think volcanoes, they think super high temperatures, which is useful. You can generate electricity from that, but it's not something that in the UK is particularly relevant. We've got the one project in Cornwall and so on, but isn't applicable to the majority of the UK. You come a little bit shallower and go to sort of 2-3 kilometres deep, and that's where your temperatures might be sort of 80 degrees, 90 degrees C. But again, that's quite specific in terms of the geology that you're on. If you go shallow and you go to sort of 200, 300 metres deep, and I was looking up the other day, the height of the Shard is about 300 metres high, sorry. So we're talking about the same height, but going underground.
Yeah.
And at that kind of depth, your temperature's around 15 degrees C, whatever the weather. And so this is where then if you put a heat pump on top of that, your energy efficiency, you can reduce the consumption by a factor of 4, your energy needs. So this is why going underground is really useful. But then to answer to your question spatially, this is where, yes, your classic solution, your garden solution would be the slinky. Then you do need a very, very large garden. You can go vertical, and they tend to be spaced out at 10 metres or so. Again, you need quite a lot of land space for that. And in the urban environment, we don't necessarily have, bukus of space available, or it's being used for something, right, in an urban environment. What we do is we can bring an inclined drilling technique, and this has come across from oil and gas, and we drill out at an incline, which allows us to take a very small surface footprint and go out underneath the building, out under a park, under a car park, whatever it happens to be, and access the ground underneath. And this is where the UK, if you like, is sitting on a giant thermal battery. But what we've got to try and do is access it. And this is what one of the things that we're trying to do. Because we want effectively the higher efficiency of the ground source of shallow geothermal to play its role in the UK's energy decarbonisation.
And so how do you see then the technology you have being rolled out and being more common than what it is at the moment? And the reason I'm saying that is because it seems as though air source feels more accessible and feels more common than what it is. But the issue with the air is the temperature in the air has got huge fluctuations, and you can't predict it either. But the temperature in the ground doesn't have such a variance.
Yes. And I think the first important thing to say is as we go through the energy transition, it's not always one technology against another. Right. Some technologies will be more applicable than others. And if you are in an individual house, you only have a certain amount of money to spend, you're probably going to go down the air source route. And that's okay. But when you get to larger systems, you probably start to talk about multi-energy sources. And this is where ground source needs to play a role, because then the higher efficiency really plays in if you're in sort of your very large kilowatt or megawatt type systems. So I think that's probably the first point, right? Because then what you can do is rely on the ground source for the bulk of the heat demand, particularly like you said with those steady temperatures that we see from the ground, and we're not as reliant on the air temperature. The other, I think, really important thing that we don't necessarily talk enough about is that energy consumption reduction that you're seeing not only reduces your energy, but it reduces your exposure to volatility in energy prices, which I think we're all, becoming increasingly exposed to at the moment, right?
So it sounds like from what you're saying then that the real benefit here is around the community heating types of scenarios as opposed to individual dwellings?
So we focus on large-scale systems. So that could be domestic, it could be industrial, it could be hospitals, it could be schools. It's more a scale question. So yes, on the individual home perspective, we don't really tend to work in that space. It's the large-scale systems, which can be blocks of flats, it can be groups of houses. It could be moving into the heat network space where you connect the school and the hospital and the shops and the houses all together, because then it's the efficiency of scale that you're starting to look at, which then allows you to use ground source, allows you to use multiple energy sources in order to basically optimize energy consumption, optimize the carbon footprint, and also optimize the cost of of heating and cooling delivered.
What are some of the biggest misconceptions then, apart from the ones that I've mentioned, that show up for you and for the organization or the industry on a regular basis?
Not sure it's a misconception, more an unawareness maybe.
Yeah.
Sometimes I describe geothermal as the invisible energy source because it's not something that people talk about. Your head, as I mentioned, goes straight to that volcano if you say geothermal. They don't know that it's available to 90% of the UK. They don't know that it's under your heat. It's local, it's renewable, and it's here, right? And I think perhaps it's that invisibility almost that's the problem. And then that plays into whoever's advising and designing systems. It plays into discussions in government on policy. It plays into discussions with investors on stepping into the energy infrastructure space. So it is something I think we need to raise the awareness on the benefits, fundamentally around energy efficiency and long-term energy efficiency that I think we need to elevate.
And what types of conversations or what projects can you talk about where you've seen actually because they've used this technology, it's completely transformed not just the efficiency, but also the what's the word I'm looking for? The desirability from an investor's point of view into a project. Do you get involved in anything of that size or of that scale?
So the some of the things that we've seen, maybe more on the investor space,
Yeah.
is when investors step into a new technology type arena, they're very risk averse. So being able to do a design of a system, we have digital twins that we apply for both the equipment on surface, but also the ground below, allows us then to step into the performance space. You can see we have digital monitoring, we have algorithms that start to learn how the system is behaving. It can optimize further, and raising the visibility of how the system is performing is then really important because it de-risks effectively then the project, right? And if you can step into that space over a long period of time, which again is what investors are looking to do, then it helps with the economics because all of a sudden you don't have ridiculous percentage rates that you're trying to match. You can bring down the return in time on the investment. And that sort of opens up the conversation then as far as people willing to invest in the space. And I think that's particularly important because, yes, there are grants available. The government has grants in certain sectors like PSDS and social housing and so on, but not everybody that applies for a grant receives one. They may have to have multiple goes at it, which means we need to open up private investment into the energy infrastructure, which means, again, you're starting to talk at scale, large system.
Let's talk now about you personally. How did you manage to get into this industry or in the role that you're in at the moment? What was the light bulb moment for you?
Well, in the UK, you're forced quite early, right, to narrow your choices, right?
So you're talking to GCS?
GCSE, A level, you have to whittle it down to sort of 3 or 4 subjects by the time you get to A level, right? And at that point, I think I was going, okay, I'm not sure I care what subject it is. I was doing maths and physics and so on, but I want to be useful, right? And I want these subjects to be useful. I don't want to study for subject's sake, if you like. So engineering popped up as a subject. I didn't know any engineers, so I didn't have a dad as an engineer or anything like this. I wasn't tinkering with cars in the garage at a weekend. So it was a bit of a hunt into the dark, if you like. But it allowed me to do that purpose piece, right? What I was doing was useful. And then when I graduated, you get a lot of banks come and try to hire engineers. You get a lot of car companies try and come and hire engineers. And neither of those really spoke to me as a subject, right? I didn't particularly want to become, an expert in a car door handle or something like this, right? And I came across an organisation called Schlumberger. And I had been working in nuclear, and Schlumberger at the time were working in oil and gas. A very technology-focused organisation. The CEO was as an engineer, and so they spent a percentage of their, about 5% of their revenue on R&D. And I was like, this is the place to be. As an engineer, you want to be involved in technology. So I've always worked in energy, first nuclear, then oil and gas. And then about sort of 6-7 years ago, when the noise around the SDGs was happening, there was a lot more discussion around the energy transition and decarbonisation. I started getting much more involved in how can the energy space how can Schlumberger, how can SLB as it is now, work in the energy space? So started with carbon accounting, circularity, and bringing all these concepts and tools into the organization. And at the same time, Celsius Energy was forming as an internal venture, where, again, sort of the founders, Cindy, Sylvain, and Mathieu, had effectively the same sort of thinking professionally. How can my skills be used in the energy transition, and what can we do about it? What do we know how to do that can apply in the energy transition? So Celsius Energy grew in France, and then they opened up operating units in the UK and the US, and I was asked to then take on the UK and open up the market, and try and get the UK into this energy source that they're currently underutilizing. Right, I think there was a report the government asked for a couple of years ago that showed that 0.3% of the UK's heating demand comes from geothermal. 0.3%. Tiny. And with all of the noise and all of the focus on decarbonisation of the electricity grid, on decarbonisation of our transport, of EVs and aeroplanes, what is hidden, and perhaps the elephant in the room, is our heat consumption. So about 40% of the energy used in the UK is for heating of our buildings. 40%. So decarbonisation of heating and cooling has to be the next big topic in the energy space. And there's a little bit of noise happening around heat pumps, starting noise around heat networks. It can only grow, right? It has to grow because it's such a huge percentage of our energy consumption.
It seems as though to me, though, that there's a consistent increase in the amount of demand that we are putting on energy, or that the demand that we have for energy. There's been a significant increase. But before I get to that bit, I'm just interested on how you made the jump from doing your A-levels and progressing there to then being chosen by Celsius to head up the UK, and just what you think kind of the 2 or 3 attributes that you had honed and either unintentionally or intentionally developed to make yourself stand out to take on this role and make a difference.
So my route started off very engineering focused, as an engineer, as a design engineer, and then you sort of step up, then you run a project, and then you run a department. And then I took a little bit of a left-hand turn, which sort of coincided with kids and trying to have a more flexible job role. And I worked much more in corporate performance. So how do you take a business and how does a business need to perform? And how do you make it the best operating company in the world, or something like this, right? So I took a very deep dive into processes and KPIs and KPOs and how you structure them.
Yeah.
And that was probably the start of understanding that there are multi-dimensions, right? You have to look at the finances, obviously, but you also have to look at social impact, and then you have to look at environmental impact. And so you start to look more in a pyramid of types of KPOs, if you like, which broadened up, I think, then at that point, my understanding of how business works and how the landscape works. And then moving then into the environmental space and the carbon emission space. I started to build, I suppose, I don't want to say the word brand, but I think that's what people use today.
Yeah, reputation, right?
A reputation around understanding the energy transition and what was needed to do that. But I think there's another piece that plays in, which is perhaps my approach to leadership, my approach to problem solving, which is much more collaborative, I think, than perhaps historically people have been, right? And in this new energy arena, this energy transition space, we do have to do business differently. We have to build different types of relationships, ones that are much more collaborative and inclusive, because we have to do things differently. Business as usual will not get us to where we need to be. So I think perhaps all of those combined together meant they went, okay, it's a new technology in a new space, working in a new environment, new industry, new customers, and new partners. There's a lot of news, right? Which means you have to then, I suppose, be able to, and we talk about that actually regularly in our team. Has the day gone by without you learning something? And chances are the answer is no. Every day there's something new.
I love the thing that you spoke to there with leadership, because you're only a leader if you've got followers. You can get a bunch of people together and you can manage them. but you can't get anyone together and lead them unless they are willing to come with you
Absolutely.
to a place that you want to go. So I think that the definition of leadership has been better defined recently than maybe what it has been in the past, where leadership have been confused with management or dictatorship or compulsion or something like that. That's
It's
not
not a
leadership.
title. Yeah, absolutely.
Yeah, that's not leadership. So the leadership definition, at least in my opinion, it's up to you whether you come with me or not, is that you're only a leader if you have followers. And it's nothing to do with your title.
It's nothing to do with your title. It's about the environment and the vision and the destination. That then, yes, hopefully helps you find the people who want to come with you on the journey. And it is about that, particularly in the energy transition space. It's a journey. Will we get everything right first time? No. Will there be bumps in the road? Yes. Will there be turns? Absolutely. But as long as we're clear on where we're headed and how we get there, both technically, but also I think socially.
Yeah,
very, very
very
much so.
sure. Because you need other people, don't you? As a leader, you do need other people, and other people need you. So it's not. Sometimes people say that leadership is isolating or can feel like on your own. Yes, I think it does it at times, or it could do. But at least when I've reflected on it myself personally, I've found that actually there are other people out there that I can connect with that will enhance me as a leader, enhance that clarity, maybe enhance the experience that my followers have in the business, in whatever sphere, as well. So I think that is quite symbiotic in terms of the way that the leaders or effective leaders work.
Yeah, it's an interesting point that you raise around sort of the isolated potential nature of leadership. And I don't want to stand on a soapbox, but when you look at, women in leadership and then you look at women in STEM in leadership, the numbers are appalling. So one of the sort of organizations that about 5 years ago I joined was an organization called Homeward Bound, which looks at leadership for women in STEM, which may sound quite niche. But it's looking at how does the sort of future leadership need to look? How does it need to behave? How do we, as we mentioned earlier, do business differently? What are the skills that you need to bring into the space to allow you to lead, to allow you to get followers, to allow you to enact change? And particularly in the STEM space, drive decisions with data for both, the planet and people. But what that does is it gives me a global network of women in the leadership space who you can always say, has anybody come across this problem? Or what would your advice be in this situation? Which allows you, like you were saying, to sort of find other people to work with and talk about how do we progress forwards here. Yeah, which is a massive support, to be honest.
And I think that sometimes leaders can forget that they can feel as, okay, I'm a leader, so that must mean I need to feel isolated. I need to feel on my own. It needs to, but what I think what we're both saying is it doesn't need to be like that. That feeling more is a sign or a flag or maybe a data point to say you need to go and find someone else.
Okay, to ask a question
that has been in that position, or there's no because there will be.
And I think the other interesting piece, actually, in the Home of Our Network is there are people who are in their 20s and there are people who are in their 70s. And I learn from both ends of the spectrum, right? Because there are things that, yes, people in their 20s, they've grown up in a slightly different environment.
I say very different.
Very different environment. And obviously people who are older than me have seen more and experienced. So being able to just go, hey, I'm feeling a little bit adrift here. What advice would you have? It's okay to ask the question, right?
All that.
Yeah.
Let's talk about energy now and about the demand. So the way that I see it is demand is ever increasing for energy, even though the population necessarily isn't increasing, at least in this country, dramatically. Do you think that will always be the case? And how do we cope with the demand for energy, especially when we look at more electrical items out on the market? So my oldest child is coming up 22 years old. When she was first born, the amount of devices that were in our house were nowhere near as high as they are now. An interesting thing, my wife clicked on an app that then told her the amount of Bluetooth devices that were available in our house, and there were 55 Bluetooth available devices in our house. Now, I know that going back to 2000, that was not the case.
Yeah. So when you get home, look at vampire energy, which is usually about 10% of your domestic consumption, which is those devices that are plugged in, that are just on standby, ostensibly.
Sucking the life out of me.
Sucking the life out of you. And using energy. But going to your original question, it's a really interesting one. And yeah, I used to sort of think, oh gosh, as like you said, more devices come online, we have more data, we have more electronic, widgets in our life. Our energy consumption can only snowball. But quite recently, there's been a lot more discussion about actually what it might start to look like, and whether it's sort of developed countries, Western countries, can reduce their carbon footprint and their energy carbon footprint. And that's where I think you have to draw the distinction between electricity and energy. So yes, we will use more electricity, but if you start to look at adoption of things like heat pumps, if you can get a division by 4 of your energy consumption, yes, you're switching to electricity, you're electrifying heat, but you have also dropped the energy that you're consuming. Same with EVs. I think it's by a factor of 2 or 3, the energy that you need per mile. So it's a switch from, gas and so on to electricity. But with all of these energy efficiencies coming in, actually, it's starting to look like we can either plateau or reduce total energy consumption. Now, these are early studies. There's obviously adoption rates that have got to play in. There's future evolutions to occur, but it's actually starting to look perhaps more positive than the past, I would have thought. Yeah.
So you're talking here about efficiency.
From overall energy consumption, whereas in our day, we sort of go, we're consuming more and more electricity. Well, electricity currently isn't the only type of energy that we consume.
Cool. So talking now to space energy and heating, what about water? Because after space would
Hot water, you mean?
definitely be hot water.
Yeah.
How to keep that temperature that we need. What options, what insights can you give to try and help address the demand for hot water?
So I think there's a scale question there as well, right? So in terms of space heating in the UK, it's around, I think 17% is on buildings, and around sort of 3% is on then domestic hot water. So I think the interesting piece there is they quite often come together. Obviously, domestically, you tend to be using the same system for both. And the same can happen if you want to use a ground source heat pump system, it can do both. And so then you bring the same efficiencies then into heating your domestic hot water as you do space heating. And the piece perhaps that to tag on to that is the needed increase in cooling. As the climate changes, as we all switch into urban environments and cities grow, there's an estimated 300% increase in air conditioning, and it's going to be needed by 2050. So if you think about all of that heat that's effectively available in buildings, you can choose to do something with it. You can release it to atmosphere, or you can try and keep that heat for use interseasonally. So if you can store it subsurface in the ground, using the ground as a thermal battery, take the heat out of a building, put it in the ground, and then in the winter when you need it, do the reverse and heat rebuilding. And this is something we have to, I think, consider more again in the systems and technologies that we use because of that anticipated increase in coolant weights.
So is this technology available already?
Yes.
So just to break this down here, I've got excess heat,
Yep.
and instead of sending that out to the atmosphere,
Yep.
I'm storing that excess heat in the ground.
Correct.
And then in colder periods, that temperature in the ground then is risen slowly. Is that temperature in the ground then gone up? Or has that remained the same 15 degrees that you'd mentioned before? And then am I pulling that heat back out?
Yes.
And then putting that into the building?
Yeah. So what you tend to see is a sort of a cycle, right? So as you inject, it rises. As you extract, it drops. And so there's a sort of a seasonal cycle that we keep within quite tight bounds, because obviously you don't want to overcool the ground and you don't want to overheat the ground. So yes, there are regulations and we do that. But that's exactly what we're doing. We're taking effectively rejected heat, waste heat, air conditioning, heat recovery. There's many ways that you can take heat and store it in the ground. And then, and that improves the efficiency of the overall system, right? And it also means we're not rejecting heat to atmosphere. So that heat can come from data centers, air conditioning, supermarkets, you name it, right? There's lots of available heat that can be recovered.
I love this. This conversation is so fascinating because, as we know, we don't lose energy. It just gets converted into something else. And we don't gain energy. It just gets converted from one thing to another. And there's energy all around us.
Yes.
Is in everything that we are so used to. And it's in terms of a resource, it's how we use that resource.
You're efficient with
as how we push and pull and direct it.
Yes.
And I think that the things that we've been discussing here is definitely been much wider and more interesting than the straight, I just want to get electricity and I want to get this power and I want to get free or cheap or whatever electricity is. How do we use the energy that already exists and control that or convert that in a way which is intentional? And then when there's too much energy in this area, we've got some surplus. Where do we put that back into something so that we can draw back from it or use it later on?
No, absolutely. And you would think very simplistically, if we generated too much electricity, you would store it in a battery. Same thing. If there's spare heat, store it in a battery. It just, in this case, your battery is a thermal battery made out of rock underneath your building.
And we're walking on it.
And you're walking on it underneath your feet. And it goes to that question about the worry about the sort of the increase of energy that we are consuming. Well, actually, if you start to get smarter with it, you start to understand the flow of energy, we start to control that and understand and to work for efficiency, then that's effectively what we're looking to do, to use the ground.
Karen, tell me one thing that you wished or that you hope people would understand with more clarity that would make all the difference to the world.
I don't know if it's a wish, so much of a pet peeve. In today's sort of energy retrofit environment, CapEx is very much king. And what I find, I guess, a little bit hard to understand is we've just gone through the Ukraine war where, prices of gas, electricity went through the roof. They haven't returned yet, right? We're still all paying more for our energy. Volatility is not off the cards yet, right? We will inevitably see, because of all of the geopolitics that's happening around the world, volatility in our energy prices. So my pet peeve is that there isn't an increased focus on energy consumption reduction, on OPEX, because if you can divide your energy consumption by a factor of 4, you reduce your volatility exposure by a factor of 4, you reduce your carbon footprint by a similar factor, and so on, right? But CapEx is still king. So I suppose my question or ask to anyone that's considering an energy strategy is look at the long-term costs to you as well as that initial CapEx.
It's difficult, isn't it, for organizations at times that have got a very fixed and precise business model that is just pointing towards that CapEx or that capital expenditure, to have them even be interested in looking at things operationally because, well, why do I care? Because I'm here just to build it and then I'm gone. There's no operational thing for me here.
Which is where it's the end user, right? It's the owner, the operator, that is then going to have to take a look at those OPEX. So it's becoming, I think, perhaps more savvy and asking the questions and saying, okay, the system is being installed. What will it cost me to run? What will this look like in 10, 15, 20 years' time? I think is something we all need to maybe educate ourselves on and ask those questions.
Karen, it's been great having you on the podcast today. I appreciate you coming to Future Build and coming here to speak to us.
Thanks for having me. Energy's the place to be.
It definitely is. And appreciate your wisdom, the way that you've put that time and effort in and you've narrowed down your focus at school and you've applied those principles that we discussed earlier on for you to be in a position where you are now. Just really grateful for what you do.
Well, no, thanks for having me.
Thanks for watching to the end. I think that you'll like this, but before you do that, just make sure that you've commented and liked below, and also that you subscribed.